Hey guys, so this is question 11 lead code, which is container with most water. It is a medium level question. So basically, the question is that you're given with an integer array height of length n. So if I'll reset this code, you'll find it out here. That is that this array has been passed to this function called max area, and this array is an array of heights of different heights, right? So there are n vertical lines. So this array basically contains this n vertical lines, and these can be of different length or height, you can say, drawn such that two endpoints of ith line are I0 and I comma height I. So basically there are two endpoints of this array which are basically defining the endpoints of the containers also. So these two, so let's take an example. It will give a better glimpse of the question. Find two lines that together with the x-axis form a container. So these lines basically that are given to us in the form of array. For example, this is the height array with 1, 8, 6, 2, 5, right? So 1 is the first vertical line, then 8 is the second vertical line, then 6 is the third vertical line is of height 6, then 2, 5, like this. There are n heights or n vertical lines are provided to us, right? And basically what happens is that these two lines together can hold some water, and we have to maximize this result. That is, we need to find out two vertical lines such that the water retained within these two boundaries, within these two vertical lines, would be maximum, right? So this is our question. Now the approach is, so first of all, if this is an height array that is given to us, then there could be two approaches. The first one is brute force, right? A very simple one, wherein what we're going to do is that we will simply take all the two possible combinations that could be there, and we'll calculate that what is the amount of water that it can retain. For example, if we want to check it here with an example, then it will be more clear. So let's start from here, right? So in the brute force, what is going to happen that suppose I have to calculate all the vertical lines, all the pairs of the lines which can be formed, and then I can have this maximum sum or maximum water that can be retained, right? So how can I calculate that? So I can do something like this, that my first pointer is here, right? I will calculate this water, how much water can be retained inside this portion. So I will say that of course, if I cannot fill this space with water, why? Because this will overflow, right? For the third, for the height, for the vertical line of height 3, right? So I can fill only this amount of water in this case, right? So what I can do is that I have to select the minimum height, that is 3, into the gap between these two vertical lines, that is 1. So the water that can be retained inside these two vertical lines would be of 3 size, right? Similarly, I'll choose the other pair, that would be 3 and 6 again. Maximum, so maximum sum for now is 3. Now we are calculating the other pair. So for the other pair also, this will be 3 into 2, that is equals to 6, right? So that this maximum will be we can overwrite it with 6, because now the new maximum is 6. Then we can go on for checking for the next pair, which is again 3 into, which is again 3 and 4, but this time the water that it can store would be 3 into the minimum one, is the minimum height pillar is this 3 height, right? And the water that it can hold would be 3 into this portion, right? So this is this portion. Basically this much water can be held if these two pillars are used. So this would be like 1, 2 and 3. So 3 from here and 3 from the vertical height. So 3 into 3 is 9. So the new maximum would be 9. Another pair could be 3 and 7. So again, because 3 is the minimum one, so the pillar that will be chosen will be 3. I mean the height, that maximum height that can be used is 3, and the water by width would be, the width that has to be selected is 4, that is 3, 4, 3 into 4, that is 12. So the new maximum will become 12. Next, similarly, the next pair would be 3 and 2. For this, the horizontal width will increase to 4 to 5, and the minimum will be 2. So here we'll get the retention of water of level 10. So of course we have this 12 already, so we'll not overwrite it with this, right? The next one is then 3 into this particular portion, basically we will be counting, right? 3 into 6, that is 18. So like this, in brute force approach, what we are doing is that we are trying for all the pairs. So once we have checked it with 3, right, and we are over with that, then we'll start with this 4 also, right? So the next thing will be that to start with 4. So now what we will be checking would be like how much water can be retained inside these two blocks. Then we'll check for these two blocks, similarly for these two, then the next two, and again the next two, like this, right? Then the next pair will start counting from the 6. So these two pairs will be counted, then these two, then the next two, 6 and 2, then 6 and 7, and so on, right? So for each pair that can possibly be there, like these two pairs would be there, then these two will be there. So basically, if n vertical lines are there, right, if n vertical lines are there, so how many pairs could be there? So for every nth vertical line, there will be n minus 1 pillars that it can form pair, it can form pair with. So kind of like n into n minus 1, right? These many combinations could exist. So basically time complexity of n square is coming here, right? So of course a brute force approach of n square time period is a little is a little, so this can be very expensive, that we will not like, right? Because we have this solution in ON also. So that is why brute force we are not using here, right? So the next approach would be something less complex, because of the because the time complexity that it will carry will be of big O of n times. So definitely we are going to use that. So let's discuss that approach now. This is approach number 2 that we will be implementing also, right? So implementation of brute force I'm not going to show, because it's quite simple. You need to use 2 for loops, and then you know that how to iterate through both of the loops and to get all the pairs. And then what you have to do is that for each of the pair you have to calculate a sum, and if it is more than maximum sum, so a global variable maximum sum you can keep, and if this new sum that you're calculating for any pair is more than max sum, then you can update that max sum, right? This is the technique that can be used but in brute force. And now a simpler approach will be by using 2 pointers, right? So let's discuss that first. So in this approach, what we're going to do is that we have to start with 2 pointers, right? So the one pointer is here with us, that is I, and the second pointer is J, right? And we'll start calculating the amount of water that it can hold, right? So initially we are saying that the max sum of the water that can be hold, or the maximum water that can be, let's not name it as max sum basically. So let's name it something else. For example, maximum water, right? So initially we are saying that maximum water that it can retain is 0 unit, right? Nextly we'll start calculating it with these 2 pointers, right? So from, if I is pointing to 0 and J is pointing to 8, the maximum water that our 2 vertical lines can hold would be, first of all, the minimum of the pillars. So in 3 and 7, of course 3 is the minimum. We cannot hold water up to of level 7, because of course this much portion will be, it will just go down the lines. So of course we have to select the minimum vertical line, so which is 3. So we have selected the minimum of the 2 bars, that is 3, of course. And how much width does this container have? So it is 8, right? So 3 into 8 is equals to 24, right? So the very first unit of water that we have got is 24 units. Now we have to search for another pair, right? That which another pair should we go for at least. So now you have to think it like this: should we move our I pointer in the forward direction, or should we decrement the J pointer? This is the next question. Now we can make this selection on this basis, that if you'll move this J pointer, suppose, right? If we are moving our J pointer and we are keeping our I pointer fixed to this place. Now think about it. If this next pillar is bigger than 7, then also the water that it is going to retain is of unit 3 into something, lesser width, those 3 into 7. But anyhow, the maximum height that we can use to store water would be 3, right? If this next pillar, which we are going to consider, is smaller than this 3, So anyhow we are going to get less water, right? So instead of moving this jth pointer means the pointer which was basically pointing to the bigger pillar, right? Instead of moving this pointer, we should move ith pointer. Why? Because in case we will get a smaller pillar, like instead of 4, if we would have here this 2, then also some different amount of water would be there, like some less amount of water would be there, and we wouldn't have updated this. But in case a bigger pillar is there, there is a possibility that we can store more water. Why? Because the upper limit is 7 here, right? So there is always a chance that we can store more water if we'll move this pointer which is pointing to a lower level bar, right? So that is why we are going to increment this ith pointer. So now the crux is that we will be moving this I pointer, right? So ith pointer will be now pointing to I is equals to 1, wherein j will still be on this same place, that is it will be pointing to the eighth eighth pole only, right? So now we'll increment the j pointer, and now j will I pointer, and I will point to this location, that is 1. So again we will be calculating the amount of water that can be held in here. So the minimum of the rods would be 4, and the amount of and the horizontal width would be of size would be 4 into the minimum width, the width would be 8 minus 1, that is 7. So it will come out to be 7 into 4, that is 28. So of course we have got a new max water, so we'll update it with 28. Again, now we have to make a choice whether to move ith pointer or jth pointer. Again, the same thing is there. If the bar that is going to be the next bar, it is less than 4, then of course we are going to get some less water. But if it is more than 4, that is 6, then there is a possibility of getting more water. So hence we will be moving ith pointer only. So now I is pointing to this second position, and now here the value is 6. So again the minimum rod is of length 6 into the distance between them would be of 6 width, that is 8 minus 2, 6, and 6 into 6 is 36. So we'll update the maximum water again, right? Again we have to make a choice, so we'll move this basically ith pointer again. So now after moving the ith pointer, we have got an option of the minimum rod of length 4, wherein the width would be of 8 minus 3, that is 5. That will give out a result of 20. We cannot update the max water, so still the maximum water that can be hold is that can be hold inside would be by I think the second and eighth rod, that is of unit 36. Then again we have to move I because it is smaller than 7, and at this point I is there. Now 7 and 7, that is both are equal, right? So we'll say that rod length would be 7, and the vertical and the horizontal width would be 8 minus 4, that is equals to 4, right? This we are talking about. So 7 into 4 is 28. So the new max water would not be updated because it's already 36 that we have got. Now the question is whether to move this 7 or the next 7, right? So you can choose any of the 7s here. Now why am I saying it? The reason is because if we'll get a new vertical rod which is more than the height of this particular rod, right? If suppose we'll try and move both of the rods, and we'll see that what will happen. So if we'll move this I, so of course we are going to get some lower value, right? So this max water is not going to be updated. Even if you'll move this one, right? So here even if you are getting this 8, then too the result will be like less than 36 only, even less than 28 also. The water that can be retained within 2 of the pillars, 7 of length 7 and 7. So that is the reason that you can move any of these, because anyhow you cannot cross this particular max water, right? So if we'll move this I, right, so we can again calculate the amount of water. It is of course lesser, right? If again we will move this particular ith pointer, so this is 7 into 7, again something which will be less than the max water, right? And this time if we'll move this 7 again some 7 units of water can be retained within these two pillars, right? And because at this moment after this moment, if we'll decrement this jth pointer, right? Now j will come here because this time j is less than I, right? So I and j are both at the same place. At this time you can just stop the process because you have calculated all the valid pairs which can anyhow somehow can give you a new max water, right? And after processing your array once, like, you have processed your array completely one time, and after this you can get a max water, that how much maximum water can I store within two vertical lines, right? So the answer was 36. So it is a very simple two pointers algorithm that we are going to implement now code wise. So let's start with that implementation also, right? So here we come. So solution part is also very simple again. So what we're going to do here is that we're going to have two pointers, right? So int I is equals to 0 and int j will be pointing to the end of the height. So that will be height dot length minus 1, of course. And we have to do the operation until I is less than j. As soon as I is equal or I is greater than j, of course, that case will not happen. So until so at that portion, we can just terminate the process, and we have to return this max sum, that max water that we are calculating. So initially we are saying that max water is 0 because, of course, here in the constant it is defined that all the elements are greater than 2. So anyways we are going to get some value which is greater than 0 for sure. So that is why we are considering the initial minimum value to be 0. And now what we're going to do is that we are going to compare that if height, right, if height I is less than height j, right, if this is the case, then of course while computing the local sum, right, int sum is equal for int local water, right, is equals to 0. That is how much water two rods can basically hold, right? So local water retention is equals to the minimum of the height. So in this particular case, height I is minimum, so we have to multiply it with the width, and width would be j minus I, of course, because I is always smaller than j. Wherein if the case is just the opposite, then we can calculate the local water by the same formula, but this time instead of using I, we will be using j. Again, we have to suppose if height I is less than height j, then in the next turn you will want that I plus plus should be done, right? Wherein if the case is opposite, then j minus minus should be done. So that is also taken care of. And the last thing would be to compare this local water that you have gathered with the max water, right? So what you can do is that you can update your max water on the basis of this particular condition, that whichever is the maximum, we have to keep that. So math.max of max water comma local water, whichever is minimum, will keep that, right? So at the end we can return this maximum water because this is what we want, right? So max water is the amount of water that is maximum for this case. So now if we'll run it for the local cases, first of all we'll understand that if there is any sort of like error, for example local water, okay, the w is capital here, so we can make it small and we'll run it again, and I think again a spelling mistake would be there, so let me correct it. So local water, so both the cases are passing. Let's submit it. So this is a very simple problem for two pointers. Using two pointers algorithm we are solving it, right? And similarly you can also try it with different you can try both of the algorithms that we have discussed. You can start with the brute force, and afterwards you can move on to this particular problem. Also you can analyze the figures by drawing some graphs. Also you can you then will understand why two pointers algorithm would work here. And if you like the video, this was all about the problem, right? So if you like this video, you can go and check out my different videos of lead code questions, because This is very important, somehow this is the thing that is going to give you a grip over others when you're trying for fang interviews or something like that. So that is why I would say that try these questions. It is very important. If you have any sort of doubt or you want some different explanation to the same question also, I'll do that. So just let me know by commenting, right? So okay guys, thank you.